This marathon has made me realize how unhealthy my family is and how dangerous it is to be unhealthy.
I know. My husband and I were at the doctor's just last week because he was getting routine blood work done. They told me that if he continues to smoke and drink so much coffee, he could develop erythromelia.
That sounds serious. What is erythromelia?
It's an abnormal heart rhythm.
Could it kill him?
With a normal, healthy heart, it would be unlikely to trigger a fatal erythromelia without an electrical shock. However, he eats so much fatty, artery-clogging food and smokes 3 packs a day.
That's awful. I hope that he doesn't develop erythromelia or any other serious heart disease.
Me too. Let's keep going and not worry about this right now.
Let's just stay here a little bit. Look, we're at the half marathon marker. I can't believe we already made it this far in such good time. I guess all that training paid off. Are you okay? Come on, just 2 more miles and we'll be done our first marathon. Come on. Come on. Come on.
You go on ahead, Court. I don't think I can make it any farther.
No, come on. We have to finish together.
I think I can feel that hamburger that I had for lunch earlier.
We've been working so long and we're so close. Come on.
My jaw's really sore, too.
Kelsey. Kelsey? Somebody help! I have to call 911. Hello? Yeah, something happened with my friend. She, collapsed. Okay. Okay, 5 minutes. Okay, that'll be good. Okay, thank you. Kelsey? Wow, it's pretty amazing that the body is able to recognize when cells need oxygen wherever they are in the body. So what happens when blood reaches the heart?
After the blood comes through either the superior vena cava or the inferior vena cava, it enters the first chamber of the heart called the right atrium. Once the blood enters the chamber, it flows to the second chamber called the right ventricle. In between the right atrium and the right ventricle is a valve called the tricuspid valve. The tricuspid valve has 3 flaps that keep blood moving the right direction. It prevents blood from going from the right ventricle back to the right atrium. The tricuspid valve is one of the 3 valves in the heart. Each of these valves have cords called chordae tendineae that stretch from the walls of the heart to papillary muscles, which hold these cords in place. After the blood passes through the right ventricle, it moves through the pulmonary artery, which carries blood to the lungs, then branches off into either the left pulmonary artery or the right pulmonary artery, depending on which lung it is going to. In between the right ventricle and the pulmonary artery is the pulmonary valve. The pulmonary valve keeps the blood from flowing back to the right ventricle after it has passed onto the pulmonary artery. When blood enters the lungs, it is blue because it is not very oxygenated. While the blood is in the lungs, it picks up oxygen and gets rid of its carbon dioxide. The blood becomes oxygenated, turns red, and returns to the heart through the pulmonary veins. The pulmonary veins carry the now oxygenated blood to the 3rd chamber, called the left atrium. From the left atrium, blood passes through the mitral valve, which prevents blood from returning to the left atrium, to the 4th and final chamber, called the left ventricle. From the left ventricle, blood passes through the 3rd and final valve, called the aortic valve, onto the aorta, which carries blood to the rest of the body.
Wow. That is very complicated. But I guess it isn't that bad. So veins carry blood to the heart. It passes through a bunch of chambers and valves, gets oxygenated at the lungs, goes back through the heart, and out to the rest of the body, ensuring the survival of every single cell in the body. Very impressive for something only the size of a fist. And I guess that's why our veins are blue. I never really knew that. Well, it looks like we're at the hospital now. Thank you so much.
No problem. I hope Kelsey is okay.
Oh my God, Kelsey, please be okay. Kelsey, please be okay. Oh, come in.
Hello. I'm Dr. McDreamy. Nice to meet you.
My name is Courtney. How's she doing?
She's doing okay. She's still unconscious, and her heart has a very slow pulse.
Oh no. I find it really hard to believe that something as small as the heart is the most important component of the entire human body. I find it very impressive, actually.
Yes, it is very impressive. Although the heart is so small, it is complicated and has, in fact, 3 layers around it. The first layer of the heart is a thin layer called the endocardium. It surrounds the ventricles of the heart and is the wall that the blood cells pump up against. It is very similar to the lining of the blood vessels. The second layer of the heart is a very thick layer called the myocardium. The myocardium is the thickest layer containing the contractile muscles of the heart. It is in this layer where the most energy is being used in order to,
pump the heart?
Yeah, it's in order to pump the heart. The third layer is called the pericardium. The pericardium is actually two very thin layers with a gap in between. It is in this gap there are no cells, just fluids.
That's pretty interesting. I had no idea that the heart had 3 different layers surrounding it. Okay, by the way, I have a question. My niece was born with a heart condition called VSD, ventricular septal defect, I think. What is that?
Well, VSD is a condition where holes form in the interventricular septum wall. The wall is in between the right ventricle and the left ventricle and prevents blood flow between them. The interventricular wall has 2 parts. The upper, thin part is the membranous part. The lower, thick part is the muscular part. The holes causing VSD form in the membranous part.
Oh my god, so it's like holes in your heart.
Yeah.
That's pretty interesting. Is it common?
Well, heart conditions are not common, but it is most common heart condition in babies.
Thank you for enlightening me about this, doctor. I always thought that her condition had something to do with the control of her heartbeat.
Nope, the control of the heartbeat is not related to this condition.
Would you mind telling me about the control of the heartbeat? Anything to distract me from thinking about it.
Sure, so the heart consists of muscle cells that contract in waves. These waves are what control the steady rhythm of the heart. A chain reaction occurs involving cells and continues until all of these cells contract. This causes all of the cells in the right atria and ventricles to contract in steady rhythm. The first group of the heart muscle cells that get stimulated by this chain reaction are in the synovial node, also known as the pacemaker. This is a group of specialized heart muscle cells located in the right atrium. They spontaneously initiate their own electrical impulse and contract. This electrical impulse reaches another area of the heart called the atrioventricular node, located in the septum. The AV node passes on this electrical impulse to the muscle cells in the ventricles. This results in the ventricle contracting a fraction of a second after the atria. A heartbeat has 2 phases. The first phase is called systole. This is when the ventricles contract and close off the AV valves and open the SL valves to pump blood into the 2 major vessels that exist at the heart. In phase 2, called the diastole, the ventricles relax, which allow the back pressure of the blood to close the SL valves and open to the AV valves.
That's really cool. So is that like how a pulse is formed?
Yes, that is how a pulse is formed. A pulse is a series of pressure waves within an artery caused by the contractions of the left ventricle. The elastic walls in the vessels expand and stretch when blood surges through the arteries. Your pulse can be measured by the back of your knees, wrist, groin, neck, temple, and top or inner side of the foot. Do you want to hear an interesting statistic?
Sure.
The average pulse rate ranges from 70 to 90 beats.
Oh my god, my pulse is not that. My pulse is higher than that.
That's okay. Stress and anxiety significantly raise your heart rate.
Yeah, I understand. So how does all this relate to the heart rate showing up on that machine next to Kelsey, the one that's like the different lines and stuff?
Well, your heart rate is controlled by the parasympathetic nervous system and the sympathetic nervous system. A heart rate is measured in positive and negative potential in millivolts, determined by pacemaker cells located in the synovial node. When calcium channels open up, they make the cells in the synovial node become more positively charged until they reach a point when they close and potassium channels open up, bringing the charge back down. This is what a heart rate would look like. It is called a QRS wave.
That's really confusing. The heart is such a complicated organ. I have another question regarding the heart. I understand that valves keep blood vessels moving in one direction, but what else keeps blood flowing throughout the body?
Since the circulatory system is a closed system, blood is contained within the heart or blood vessels at all times. The blood vessels that are part of this closed system create a network to to help keep blood flowing in one direction.
So what exactly carries these blood vessels throughout the body?
Arteries are large muscular blood vessels that carry blood away from the heart, and veins are large blood vessels that carry blood to the heart. Arteries have 3 layers: an endothelial layer, a middle layer of smooth muscle, and an outer layer of connective tissue. The connective tissue layer is also known as the tunica adventitia layer, and along with the connective tissue, it is composed of collagen and elastic fibers. These fibers allow the arteries to stretch to prevent overexpansion. The layer of the smooth muscle is also known as the tunica media layer, and it is thicker in arteries than it is in veins. The endothelial layer is also known as the tunica intima layer, and it is composed of an elastic membrane lining and smooth endothelium. When blood leaves the heart through the aorta, it enters arteries, which divide into smaller arteries called arterioles. These
Arterioles?
Yeah, arterioles. How'd you know?
I learned that in biology class in high school.
These arterioles branch off into even tinier vessels called capillaries. Capillaries are the smallest of the blood vessels, and their cell walls are only 1 cell thick, so gases and nutrients can diffuse through their cell walls. They also connect the arterial and venal systems. Capillaries make up a network so extensive that about 100 trillion cells in the body lie within 125 micrometers of a capillary.
Wow.
Capillaries then merge to form larger vessels called venules, which then merge to form a vein, which is a large blood vessel that carries blood to the heart. The veins are composed of 3 layers, just like the arteries, except they are thinner and less muscular, because by the time blood reaches the veins, it is under much less pressure. There are some valves in the veins that keep blood flowing in the right direction. These veins merge to eventually form the superior and inferior vena cavas, and at that point, blood returns to the heart. This is how blood flows throughout the body.
Wow, that's really interesting and really complicated. So how does all that relate to blood pressure?
Well, the contraction of the heart moves blood through the arteries with great force. The force that blood exerts against the inside walls of the blood vessel is known as blood pressure. It is the highest against the 2 main arteries.
Wow. So how is blood pressure measured? Because I know different studies and sometimes you go to the doctor to get your blood pressure taken, but I really have no idea how that works.
It is measured in the artery that supplies blood to the arm. A trained person would inflate a cuff and place it around a patient's arm, which temporarily stops the flow of blood through the artery. Connected to the cuff is a gauze containing a column of mercury that rises as the pressure in the cuff increases. The doctor then releases the air in the cuff and listens to the artery with a stethoscope and watches the column of mercury. The systolic pressure is the first sounds of the blood passing through the artery when the ventricles contract. In a normal adult, the systolic pressure is about 120 millimeters of mercury for males and 110 millimeters of mercury for females. The disappearance of the sound, which indicates a steady flow of blood through the artery in the arm, is called the diastolic pressure. In a normal adult, the diastolic pressure is about 80 millimeters of mercury for males and 70 millimeters of mercury for females.
Are there any problems that could result from blood pressure? I've heard of high blood pressure and low blood pressure.
Well, yes, you're totally correct. High blood pressure, or hypertension, is a leading cause of death in many countries. High blood pressure can place a strain on the artery walls and increase the chance that a vessel will burst. There is also low blood pressure, which is called hypotension. Hypotension is blood pressure that is low enough that the flow of blood to the organs of the body is inadequate and symptoms and signs of low blood flow develop. If you have hypotension, you might experience dizziness, fainting, and lightheadedness.
Wow, thanks for telling me. Now I will know if I have high or low blood pressure. I'm getting really worried about Kelsey. Are you going to do anything, or are you just going to let her sit there?
Yes. Back up. We are going to send an electrical signal through her body because the body runs on electricity. That should get her blood pumping again.
Okay, I'll leave the room.
Claire! Claire! healing, they revived you.
So, how did this happen? And what does my circulation have to do with any of this?
Well, what happened is that you were running, and your heart could not keep up with you because you have been eating very unhealthy foods. The unhealthy foods have contributed to clogs in your arteries, which can slow blood flow tremendously. When you were running, your body needed so much oxygen to circulate to your body, and it couldn't because of the clogs in your arteries. So, now to answer your questions about circulation. There are two types of circulation: pulmonary circulation and systemic circulation. Pulmonary circulation is when the blood travels between the heart and the lungs. Systemic circulation is when the blood travels between the heart and all other body tissues. Most likely, your heart attack was interfering with the systemic circulation because of the clots that occurred from the fatty foods that you have consumed.
Thanks for that information. But I was wondering, what are some more details of the pulmonary and systemic circulations?
Okay, so for the pulmonary circulation, there are veins called pulmonary veins. The oxygenated blood flows into the venules, which merge into the pulmonary veins that lead to the left atrium of the heart. There are 4 pulmonary veins altogether, 2 for each lung. These veins are among the few veins that carry oxygenated blood. On to the systemic circulation. Coronary circulation is the subsystem of the systemic circulation that supplies blood to the heart itself, and the coronary arteries supply blood to the heart. A disease that can result in the systemic circulation is atherosclerosis, which is characterized by the buildup of fatty materials on the interior of walls of the coronary arteries. Also, the thing that supplies the liver with oxygen and nutrient-rich blood and carries away waste is called the hepatic portal circulation. Renal circulation supplies blood to the kidneys, where wastes are filtered and removed.
I'm not feeling so well again.
Can I get a crash cart in here? Uh-oh. Clear! Come in. Hi, Courtney.
Hi, where's Kelsey?
I'm really sorry to tell you this, but Kelsey passed away.
What?
It seemed that your friend had developed an arrhythmia, which is an abnormal heart rhythm.
Are you laughing?
I'm not laughing.
She was talking about that earlier, but I thought you said her heart was okay.
Well, yes, it seems so, but Kelsey was not the most healthy eater. On top of that, the stress from the heart attack, it had dried her system out. The arrhythmia developed and was then triggered by the electrical shock used in the hospital to keep her alive. Inevitably, with the arrhythmia being so small that it was undetectable, your friend would have died within the next 6 months from her horrible dietary choices. I'm so sorry for her loss. But I got you. Let's go.
You know what? I feel like doing something really fun. Let's go swimming.
It's gonna be really fun.
Yeah, so warm.
So very warm. Okay, ready? We're gonna jump in together. 1, 2.
Caitlin is dead.
Claire! Claire!
She's alive. Are you okay? She's whiplash.